Right. We are doing a question from calorimetry. Right. Let's read the question first. I hope you can see the question here. A 1.5 kilowatt power heater kettle is used to raise the temperature of water 2 kilogram from 293 Kelvin to its boiling point. The heat capacity of the kettle is 1000 joules per Kelvin and the heat loss to the surrounding is 2%. Find the time taken to reach the boiling point. Right. So this is a calorimetry question. So let's look at the equations first and go through the question. Let's look at the data given to us first. So here we have 2 kilograms of water and the heat capacity of kettle, that is, yes, 1000 joules per Kelvin, and the boiling point. We should know the boiling point as well. Right. Let's look at the equations first. So we need actually very few equations. Q equals mc delta theta, and one of the main equation in calorimetry questions is heat supply is equal to heat gain. So we should clearly understand heat supply part and heat gain part. And the other equation, power equals energy divided by time. These equation actually is really helpful when we are doing this question. Right. Let's get into the question now. Yes, 2 kilograms of water, we need to increase it from 293 Kelvin to boiling point. Boiling point of water is 100 degrees Celsius. So 293 Kelvin means 20 Celsius. So the difference, temperature difference we are looking for is 80 degree Celsius. Right. Let's apply Q equals mc delta theta equation for water and kettle as well. So here water, if you apply Q equals mc delta theta, mass of water 2 kilogram and specific heat capacity 4200. Actually in this question 4200 is not given. So if it's not given, yes, we have to use it 4200. Right. Then temperature difference is 80. So this is the heat required from water. Right. If you are getting into kettle, actually kettle also at the same temperature with water. So initial temperature of kettle, it has to be 20. So final temperature 100 again. So difference is 80. And we are given heat capacity. So heat capacity into temperature difference, we are getting the total heat required. So this is the basic amount of energy required for this. Right. And again, we need to remember this 20% of heat loss. So let's write the heat supply and heat gain equation. Yes. So 1500 is heat supply. Let's apply these values into the equations now. Heat supply and heat gain. Right. Heat supply is 1500 into time, and that's it. Then we have water, right? We have water, and then we have kettle. Yes, there's one more. What is it? Yes, the heat loss. Heat loss to the surrounding we have to consider. That is also a consumption, certain type of. Right. Water, it mc delta theta. So mass 2 kilogram, 4200 that into 80. Kettle, yes, 1000 that into 80. And loss, yes, they are telling 20% of this is loss. So 20% of this means 1500 T into 0 0.2, 20%. See, 20 divided by 100, so 0 0.2. Right. So 0 0.2 into, yes, 1500 T. Right. Now we have the equation. So let's simplify it. 1500 T equals to, so when we multiply this value, 4002 into 4280, let's multiply 2 into 4280, we are getting 2 into 4280, yes, we are getting 672 into 10 to the power 3. Right, here we get easy 10 80 into 10 to the power 3. Yes, 1500 into 0.2 is, yes, 300 and 300 t, right? So let's take 300 to this side. So 1500 minus 300 t, that's 1200 t. So when we add these two, 672 and 80, that is of course 752 into 10 to the power 3. So here t equals 752 into 10 to the power 3 divided by 1200, and we are getting answer as 626.6 seconds. So if we divide it by 60, we are getting it from minutes, right? So this is the answer, 626.6 seconds. So here applying heat loss is the key part here. So if you can really apply the values for supply part and the gain part, if you can clearly identify supply side and demand, the required heat gain part, you can easily do calorimetry questions. How was it? If you are okay with the question, if you could do the question, that's great. And if you couldn't, yes, you are not good with theories, so go through your theories, follow this method again and again, so you will be familiar with the equations and questions. Find similar type of questions and do them again and again, so when you see this question in a paper, so it will be really easier for you to do it, so you are fine with calorimetry. So this is just only one question. So again, I'm telling you to find similar type of questions, and if you are good with equations, then you can go with the simplification, because when you are doing it again and again, you will be fine with your calculations and all that. First thing you should remember the equations. So work on with that. Good luck.